Hello again. Today we're going to be talking about normal quantiles and how we can use them to solve real world problems based on normal distributions. So let's say, for example, I needed to calculate an X score based on a probability. Normally it's the other way around. I have an X score and I want to know the probability of being less than or greater than that X score. Now it's the other way around. I have a probability, but I need to know what X score is going to give me that probability. So let's say I have a mean, I have a standard deviation that's been given to me, and I have a probability of X being less than some value, and I need that value. Well, that's actually the opposite of what I'm normally asked to do. So what I do is I follow the normal steps. I go to statistics, I press F5 for distributions, I press F1 for normal, but now since I'm doing the opposite of what I would normally do, I press F3, which is inverse normal. So now I'm allowed to do the opposite of what I would normally do. All right, so what I do is I make sure that my data is variable and I make sure that the tail is left because I was given the probability that X is less than or equal to a certain value and I need that value. Okay, and I'm just plugging in 85%. Let's say that I needed to find the value so that 85% of the data is less than that value. Let's say I was given that the standard deviation was 15.5 and that the mean was 120. So I enter all of that in and I go down to execute and I get a value of 136. So what does that output mean to me? That means that if I have a normal distribution where the mean is 120, which is what I put into the calculator, and the standard deviation is 15.5, then 85% of the data is going to be below 136.06. Right, so that's what that number 136.06 means. Now let's say I don't have mu, or I don't have sigma, or I don't have both. I would have to find a z-score. So I know the probability that z is less than or equal to some value of k, but again, I don't know what k is. Well, I go through the exact same process of going to 2 for statistics, pressing F5 for distributions, pressing F1 for normal, pressing F3 for inverse normal. But now, since I don't know either the mu or the sigma, if I don't know one of them or I don't know both of them, then I go through this process of changing sigma to 1 and changing mu to 0 because that's the standard values for those variables. Make sure the data is variable and the tail is left. I'm again going to use an area of 85% just to kind of prove a point. And I'm going to make sure that sigma is 1 and mu is 0. So now I execute again. And I get a value of 1.036. Well, what does that 1.036 mean? That means on a standard normal distribution where the mean is 0 and the standard deviation is 1, 85% of the data, just like before, is now below a z-score of 1.036. So that allows me to compare the z-score that I just found with the x-score that I found earlier. They are in the same position on their respective normal curves. So this can be helpful if I need to find mu or sigma. I will also need a formula that we talked about before that says that the z-score is equal to my x-score minus my mean of mu over my standard deviation sigma. So here's an example. Let's say I know the average pig weighs 440 pounds and that 95% of pigs weigh less than 620 pounds. What would the standard deviation be? And how many pigs weigh less than 400 pounds. So the first thing I need to do is find the standard deviation. So again, I'm going to go to inverse normal just like I did in previous slides. So you can follow those steps again. The tail is going to be left. The area is going to be 95% or 0.95. But since I don't know my standard deviation, I'm going to plug in a standard deviation of 1 and a mu of 0 so that I can get a z-score. So the z-score that I get from my calculator is 1.64485 and so on. Okay, so what that means is that z-score of 1.64485 and so on is in the same position on the standard curve as my value of 620 is on my normal distribution. So I'm going to use the formula to find sigma. Z equals x minus mu over sigma. Well, the z-score I know is 1.64485 and so on. My x-score that's in the same position as that is 620. My mean is 440 and I don't know my standard deviation. So there's the equation. I only have one variable to solve for, and so the solution is that sigma is 109.44 or 109.43. All right, so now I can figure out the second part. Now I can figure out how many pigs weigh less than 400. So now I'm doing what I would normally do, and I go to normal CD instead of inverse normal. My lower is 0, my upper is 400, and I now use my sigma, which I now know. I use the mu, which I already knew, and my calculator says that the probability is 35.7%. Okay, that's how many pigs weigh less than 400 pounds. All right, so in a last example, we know that 2% of the drivers travel at least 85 miles per hour and 13% of them travel at most 70 miles per hour. So what is the average speed and what is the standard deviation? So now I don't know the mean and I don't know the standard deviation. So I have to figure out both. Let's first of all figure out the Z-scores for 85 miles per hour and for 70 miles per hour. So I'm going to inverse normal, the tail is left, and I'm using an area of 98% because if 2% of drivers travel at least 85, then I know that 98% of drivers travel less. So I'm using a left tail with 98%. I'm using sigma is 1 and mu is 0 because I don't know either one, so I'm hoping for a Z-score, and the Z-score is 2.05. I do the same thing with the 13% that travel at most 70. So again, it's a left tail, the area is 0.13, and again, sigma is 1 and mu is 0, and my Z-score is negative 1.126. All right, so those are the Z-scores that match up with 85 and 70 on my distribution. So now I use the formula. The first time I use it, I'm going to use the Z-score of 2.05 and the X-score of 85 because those are in the same place. But I don't know mu and I don't know sigma, so I will leave those as variables, and I will rewrite the equation so that there are no fractions and I have everything in terms of sigma and mu. Then I use the second Z-score and the X-score of 70 that it matches up with. Same formula, and again, I rearrange it in the same way so that there are no fractions. So now I have a system of equations with sigma and mu, and so I can solve that using technology. I can solve it using substitution or elimination. I decided to use elimination and subtract the two equations. If I do that, I get that some number 3.18 times sigma is going to equal 15. The mu's are going to subtract out. That's why you don't see them. And so when I divide, I get that sigma is 4.71677 and so on. Then I can use substitution and plug that value of sigma into the first equation. I could have just as easily plugged it into the second, but I just randomly decided to plug it into the first. And when I do, I get that equation. I can solve that for mu, since that's the only variable, and get that mu is 75.31, and so on. So what does that mean for my problem? Well, I've answered the question now. Mu is my average speed, and so my average speed is 75.3. Sigma is my standard deviation, so that is 4.72 miles per hour. So that's how you can use Z-scores and X-scores and use your calculator wisely to figure out a missing mean or a missing standard deviation using Z-scores. If you have any questions about that, please let me know, and I will see you tomorrow.